Hello, so in this lecture we are going to talk about the classification of solar cells. In the previous lecture you learned what is the fundamental working principle of a solar cell and that we use semiconductor materials to make solar cells. Now we will learn if there are any other materials other than silicon that are used for the fabrication of solar cells. If yes, can we classify our solar cells based on the materials? The answer is yes, we can also classify them based on the technology or based on the design of the device. So let us first talk about the material-based classification. As I mentioned before, that 90% of the currently commercially available solar cells are made of silicon. In addition to silicon, now there are a lot of other materials that are being explored. Research is going on in order to improve the overall efficiency of the solar cell. So whenever it comes to any technology, what do we want to do when we improve the technology? It is either in terms of improving the efficiency or reducing the overall cost. Or sometimes when the fabrication method can be, for example, changed from individual or serial process to batch process or continuous process, that reduces your overall cost. So these are the two things that we are always trying. So here also, in the case of solar cells, we have different new materials, several new materials that people are working on. In addition to silicon, what do we have? We have some semiconductor compounds. So this is a separate class because these are compounds, not elements. We will talk about which types of semiconductor compounds we use. Now there are also something called as organic solar cells. So what is organic first of all? You all know that organic materials are the materials based on hydrocarbons. But the word organic, the term organic can be a little bit confusing because nowadays people are using this word commercially. You can buy things like organic milk and organic rice and organic clothes even. What do they mean by organic? In principle, they mean that when this rice was grown, for example, there was no inorganic fertilizer that was used, but organic fertilizers were used. Now, organic fertilizers, just remember, are not always natural. So do not confuse the word organic with natural. All the polymers and plastics are organic, but they are not natural. Of course, the plastics and polymers are synthetic. So here when we talk about the solar cells, we are talking about organic materials, but they are mainly polymers or plastics. Okay, and then there is a fourth category, others, where all the new types of solar cell materials that are coming up, I have currently listed. Of course, if one of them becomes very popular, then we will probably have a separate category for it. Okay, so let's first talk about the silicon itself. Silicon is a crystalline material. You have what is known as the diamond crystal structure. What is diamond crystal structure? These are two interpenetrating FCC crystal structures, and that is the structure that silicon has. Okay, but for solar cell purposes, do we need crystalline silicon or we need amorphous silicon or we need polycrystalline silicon? Which one will be better? And which one is more compatible with the manufacturing techniques and which one is more expensive and so on. So this is something you need to understand. Okay, so what happens? We can use monocrystalline, or which is a single crystal silicon, and we can also use the polycrystalline silicon material. In addition to that, we can in fact even use amorphous silicon material for the purpose of solar cell fabrication. Now, if you have seen large solar panels outside, and if you take a close look, you will find that there are two different types of silicon materials. Although it's very difficult to find out the difference, but there is a very small difference in the color. One looks a little more bluish and the other one looks a little more grayish. So this is because one of them is monocrystalline and the other one is polycrystalline silicon. So we will discuss in the coming lectures how do we prepare a monocrystalline silicon material and how do we slice it and how do we make wafers out of it. But for now, just understand that we use monocrystalline, polycrystalline as well as amorphous silicon material, and one analog of the amorphous silicon material is the hydrogenated amorphous silicon. So all of these different types of silicon are used for solar cell fabrication. Okay. Now coming to the semiconductor compounds. So these compounds can also be again further classified as chalcogenides and 3,5 compounds. So what are chalcogenides? Chalcogens are actually compounds of the group 16 of the periodic table. It is also the oxygen group. So if any compound contains a chalcogen material or element, then it is called chalcogenide. However, oxides are generally not known as chalcogenides because oxygen is a very common material. So only the heavier elements, when we use when they are a part of the compound, then they are known as the chalcogenides. 3,5 compounds, that is very simple. As the name suggests, it's group 3 and group 5 elements. When you make compounds out of them, then you have 3,5 compounds. So now here are some examples. Examples of chalcogenides are one very common example, and this is something that is widely used nowadays in semiconductor in the solar cell industry, that is known as the cadmium telluride. Okay, copper zinc tin sulfide, copper indium gallium diselenide. This is also again a common material which shows pretty good efficiency. So these are some of the examples of chalcogenide materials. Okay. Now when we talk about the 3,5 compounds, one very common material is gallium arsenide. And then there are some other examples of 3,5 compounds. In fact, there are many more examples than what I have listed. You can find them out. Okay, coming to organic materials. So organic materials, as I said already, these are polymers. So you can use multiple different polymers as long as you can, you are able to have electron transport after the incident photon. But some examples again are PPV and polyacetylene. There are various other conjugated polymers, and one more example of an organic, it is actually a carbon material, that is Buckminster fullerenes. Since it is elemental carbon, you should not call it organic because it's not a hydrocarbon, it's just carbon. But in any case, Buckminster fullerenes are not directly used. They always have a medium, a resin or something to bind them together, and that resin is typically an organic material. So these are also organic or sometimes also called hybrid materials for the purpose of making solar cells. Okay. Now in the others category, there are some very interesting things here. Something known as the dye-sensitized solar cell. So there are multiple nanomaterials that have been developed for the purpose of making solar cells, because in the case of nanomaterials, you can chemically synthesize them in such a way that you have tunable properties. You can already kind of decide on a property and then accordingly modify your synthesis. So several nanomaterials have been used for solar cell fabrication purposes. Among them, the dye-sensitized materials are most commonly used. So this class is known as, so this is also a class, and there are multiple examples of nanomaterial based dye-sensitized solar cells. Perovskite cells. Perovskite is actually a type of crystal structure. You can learn about that. So any material that has a perovskite type crystal in it, that is known as the perovskite material. Typically, these perovskite crystals are mixed with organic materials, and therefore these are hybrid materials. These are used for solar cell fabrication as well. Okay, another example is quantum dots. So quantum dots are nothing but very, very small particles, typically smaller than 5 nanometer. And why do we call them quantum dots? Because when the particle is so small that the laws of physics, the standard laws of physics don't work, and you have to actually take into account the quantum mechanics laws. That is when we start calling them, instead of particles, we start calling them quantum dots. So there are different types of quantum dots, colloidal solutions of the quantum dots that are being used for the purpose of solar cell fabrication. Okay, So now I told you that the second classification will be based on the design of the device, which is also related to the technology. So we actually use two primary technologies for making the solar cells. One is wafer-based technology and the other one is thin film-based technology. So wafer, as the name suggests, that it is a slice of something solid, typically silicon wafers. So wafer-based technology is used for crystalline silicon, of course, gallium arsenide, and also some other 3,5 compounds. But thin film technology is more widely used because thin film can be made out of amorphous silicon, various different polymers. So you can use organic materials there, chalcogenides, perovskites, and nanomaterial based cells and so on. They can all be, they are all compatible with the thin film technology. Now, the thin films are actually, you can grow a thin film of something onto a wafer also. So on a very solid substrate, you can grow a thin film. But you can also print a thin film, screen print for example, onto a flexible substrate. So that way you can make flexible solar cells. Now what is the advantage of having a flexible solar cells? You can have your window curtains, for example, that are flexible and then they might be also able to harvest the energy of the sunlight. So flexible electronics, it's a whole new field. There are many advantages of having flexible devices, wearable devices. So thin film technology offers that advantage. Of course, many materials are also lightweight, and as I said, because some of these are new materials, we are also trying to improve the efficiency. Okay, but on the other hand, when it comes to wafer-based technology, in fact, when it comes to silicon technology, there is one big advantage. For the semiconductor industry, a lot of technology was already developed for silicon. For example, even the growth of a single crystal silicon. This technology was already there and it has been there for the past several years for the purpose of semiconductor device fabrication, IC chips fabrication. So the same technology can be easily used and transferred to solar cell fabrication, and that is one very big advantage, and that is why silicon has also immediately become so popular. So that is one advantage. In addition, as I already mentioned, silicon is available in the sand, so we have a lot of material available. It is also non-toxic and safe material to work with. So these are all the advantages of the silicon-based or wafer-based technology.